Good morning and welcome to Mission Control Houston and Space Station Live. Although we're coming to the end of a busy week for the Expedition 36 crew, there's still more to come tomorrow with the launch of the Japanese Kunitori H2 Transfer Vehicle number 4 from the Tanegashima Space Center in Japan. That's scheduled for 2:48 p.m. Central Time, but in the meantime, the International Space Station Flight Control Team is here in the Space Station Flight Control Room, watching over all of the crew's activities. Flight Director Tony Sakachi is leading them today, and Anna Fisher is assisting as Capcom. The Expedition 36 crew is now more than halfway through their day, which began at 1 a.m. Central Time. They are Russian Commander Pavel Vinogradov, U.S. flight engineers Chris Cassidy and Karen Nyberg, European Space Agency flight engineer Luca Parmitano, and Russian flight engineers Alexander Misurkin and Fyodor Yurchikhin. Cassidy, Vinogradov, and Misurkin launched into space on March 28th and docked a few hours later, so they've now spent 126 days in space. Nyberg, Parmitano, and Yurchikhin followed in their footsteps on May 28th, so they've now spent 65 days in space and at the space station. Together, the crew is currently orbiting 260 miles above the South Pacific Ocean and heading towards the coast of Chile. This week has been a long one for the crew since they didn't get much of a weekend thanks to the arrival of the Russian transfer vehicle Progress 52 on Saturday. That vehicle brought almost 3 tons of supplies and equipment when it docked to the station's Pirs docking compartment at 9:26 p.m. Central, and the Russian members of the crew and Commander Pavel Vinogradov in particular have been working steadily to unpack it since the hatches between the two vehicles were open on Sunday. Meanwhile, the crew members on the U.S. side of the space station have spent much of their week getting ready for the next vehicle scheduled to visit, the HTV-4. Its launch at 2:48 p.m. tomorrow will begin a week-long journey to the space station, culminating in its berthing at 6:29 a.m. Central on August 9th. Flight engineers Karen Nyberg and Chris Cassidy will be in charge of capturing it with the space station's robotic arm. As you can see here, how that activity will work. And then they'll bring it in for berthing to the Harmony node. They've been practicing for that task all week with the station's robotic work stations inside. Another activity that took up a good deal of time this week was the ocular health experiment. That's part of a new effort to gather data on the effects that long stays in space have on astronauts' vision. Over the course of the week, Nyberg and flight engineer Luca Parmitano each performed regular eye chart exams of their eyes, checked the pressure in their eyes with tonometers, and looked inside their eyes with fundoscopes and ultrasounds. They're the first to participate in this new study and will be doing such checkups every month while they're in space. They started in June, so this was their second round of exams. The equipment they used was delivered by SpaceX 2 earlier this year, and the experiment is expected to last about 4 years in all. Nyberg and Parmitano were also taking part in other studies that looked at various aspects of astronaut health this week. They've both been on special diets for all or part of the week as part of the Pro-K study, which is aimed at determining whether changes in an astronaut's diet can help decrease the amount of bone loss they experience during long stays in space. And every morning, right after they wake up, and every night before they've gone to sleep, they've performed runs of the reaction self-test experiment, which is aimed at trying out a way for astronauts to objectively assess whether fatigue might affect their performance in space. Nyberg did some work yesterday getting the InSpace 3 experiment set up, and today she's starting a new run in that experiment. It looks at how magnetic fluids are influenced by magnetic fields and microgravity, which could help engineers here on the ground design structures such as bridges and buildings to better withstand earthquakes. And both the U.S. side of the space station and the Russian side have been doing some spacewalk-related work this week, with Cassidy and Parmitano continuing their efforts to help teams on the ground troubleshoot the issue that Parmitano experienced during his spacewalk last month, where a water leak developed in the suit and made it necessary for the spacewalkers to end their day early. Cassidy spent some time in the Quest airlock today, in fact, on an activity referred to as scrubbing the water loops on their spacesuits. That's part of the work necessary to keep the suits clean between spacewalks and is also part of the continuing troubleshooting effort. Meanwhile, on the Russian side of the station, flight engineers Alexander Misurkin and Fyodor Yurchikhin are making preparations for their spacewalk on August 16th. They'll continue work started on their previous spacewalk together to prepare the station for the arrival of the Russian multipurpose laboratory module. Today, they're gathering tools for that. And that's what's going on in space this week. This is Mission Control Houston. We're seeing a live view here inside of the Kibo laboratory where Karen Nyberg and Luke Parmitano are working together to seal up the Missy 8 experiment that was retrieved on the August 9th spacewalk. They're working to make sure that that experiment gets well sealed so that it will protect the experiment between now and the time that it makes it back to Earth so that researchers on the ground can get a good look at exactly how it survived out in space. The Missy 8 experiment is a test bed for materials and computing elements attached to the outside of the space station. The materials and computing elements are being evaluated for the effects of atomic oxygen, ultraviolet, direct sunlight, radiation, and the extremes of heat and cold. The experiment allows for the development and testing of new materials and computing elements that can better withstand the rigors of the space environment. And it's hoped that the results will provide a better understanding of the durability of various materials and computing elements when they're exposed to space, with applications in the design of future spacecraft. As I mentioned, that experiment was retrieved from the exterior of the space station during the spacewalk on August 9th, and now Parmitano and Nyberg here are sealing it up so that it will be protected between now and the time it makes its way back to Earth, and researchers on the ground are able to open it back up and take a look at how the materials fared in the space environment.
МКС в Первом канале. На связи. Саша, забыл тебя спросить по ТВ. Он пока остался, мы его что, оставляем, выключаем, какие рекомендации будут?
Не, ну свет выключаем, Паша.
Хорошо.
Cancel session, Luca on 2.
Go ahead, Luca, on 2.
We are not very happy with the result of the seal that we got. While we were moving it, there was a fold that created, and we're just not happy with the results. So we were wondering if we should just cut it open and reseal it. I think we can do that, and let us know what you think about that.
And Luca, if you feel it'll give you a better seal, I think there's plenty of material there to do that, and you have a go to give it another shot.
As you can see, this Missy 8 experiment is a little bit unwieldy, and Luke Parmitano there reporting to the Payload Operations Center in Huntsville, Alabama, the Marshall Space Flight Center, that they're not quite happy with the seal they were able to get, and since they want to do as much as possible to protect the experiment between now and the time it makes its way back to Earth, they're going to open it back up and try again to get a better seal. Missy 8 is part of a long line of Missy experiments. The acronym stands for Materials International Space Station Experiment, and NASA's conducted several of those to determine the best materials that survive best in the space environment since the Space Shuttle program and Mir. Missy 1 and 2 were delivered to the space station on STS-105 in August of 2001. And that kicked off the first round of Missy experiments. They were returned in 2005 on STS-114. And then the next set was deployed. The most recent Missy experiments to be returned were 7A and 7B, which were delivered to the space station on STS-129 in 2009 and then returned on the second to last shuttle mission, STS-134, in 2011. This particular Missy experiment is actually planned to be returned to the ground on board the SpaceX Dragon capsule as part of the SpaceX 5 mission. Because it is rather large, it needs a different vehicle to carry it down. Most of the vehicles on the space station don't actually return to the ground, but burn up in the Earth's atmosphere. And so SpaceX is one of the few ways to get it back to the Earth at this point. The black machine that the crew is running the bag through there to seal it is a heat sealer equipment. It ensures that they get a good seal. It's airtight and, again, protects those materials that still have a little while before they'll make their way back to Earth. The next big event on the space station horizon is the launch of the fourth Kunitori H2 transfer vehicle from the Tanegashima Space Center in Japan on Saturday. That's scheduled to take place at 2:48 p.m. Central Time tomorrow, and you'll be able to watch it here on NASA TV with coverage beginning at 2 p.m. HTV-4 is going to be carrying to the station experiment samples and equipment, including one called FROST, an acronym for Freezing Refrigerator of Stirling Cycle. That's a refrigerator that's able to maintain a negative 70 degrees Celsius temperature and stay cool even when it's without power. Another experiment brought up will be the ICE box, ICE standing for the ISS, Cryogenic Experiment Storage Box. It's another way to keep experiments cool during the flight to the space station when it's not powered. And HTV will also be carrying another eyeball experiment, which is a re-entry data recorder that will relay information on the HTV's return to Earth and its burn up in the Earth's atmosphere when its stay in space is over. In addition, there's also supplies, food, water, and clothing for the crew aboard. HTV-4 won't actually make it to the station until August 9th, when it's scheduled to be brought in for berthing to the station's Harmony node at 6:29 a.m. Although most of the other vehicles that visit the station dock automatically, HTV is captured using the space station's robotic arm and driven by the crew to the Harmony node. You can see it here in this graphic as it approaches the station and moves in within reach of the space station's robotic arm. At this point, Karen Nyberg and Chris Cassidy would be at the robotic workstation inside, maneuvering the arm to first capture it and then bring it in for a berthing on the station's Harmony node. As I mentioned, the crew has been spending a good deal of time this week brushing up on their robotics training to ensure that they'll be ready for that task when the time comes. Although they go through extensive training for it while they're still on the ground before they even launch to the space station, it's important that they take some time to refresh their training while in space. And so they've done that several days this week and will continue next week. Again, coverage of the HTV launch tomorrow will begin at 2 p.m. Central here on NASA TV, with the launch actually scheduled for 2:48 p.m. Central. Among the supplies delivered by Progress 52 last week was tools and spare parts needed for the ongoing troubleshooting of the spacesuit that Luca Parmitano wore on his and Chris Cassidy's July 16th spacewalk. That spacewalk was ended just an hour and a half after it started due to a water leak in Parmitano's spacesuit. And engineers here on the ground have been looking at what caused that water to build up since then. They completed a second round of troubleshooting last week, and the team has been assessing the results and next steps. They were able to isolate the failure to the spacesuit's primary life support system, which is essentially the backpack of the spacesuit, and found 4 potential suspect components in that system: the sublimator, the gas trap, the condensate water relief valve, and the water separator. Today, Cassidy is spending part of his day in the Quest airlock, supervising the scrubbing of the cooling loops in the U.S. spacesuits as part of the regular maintenance needed for the suits, and also to continue helping with the troubleshooting activities. While he's doing so, on the Russian side of the space station, Alexander Misurkin and Fyodor Yurchikhin are getting ready for their next spacewalk, which they'll be wearing the Russian Orlan spacesuits in just a couple of weeks. That spacewalk is set for August 16th, when they'll be working to get the station ready for a new multi-purpose laboratory module. They're gathering the tools they'll need for that work today, and some of the activities they'll be doing on the 16th include routing power cables from the Russian segment to the Zarya module, and continue the routing of an Ethernet cable from the Zarya to the Poisk module. And they'll also set up another suite of experiments on the hull of the Poisk module as well. This is going to be the second of 3 spacewalks that Misurkin and Yurchikhin will conduct together. The third is coming up on August 22nd. Large portion of Flight Engineer Karen Nyberg's day has been devoted to the InSpace 3 experiment, which she got set up yesterday inside the space station's microgravity science glove box. This is some video of her working earlier today at the glove box on the InSpace 3 experiment. InSpace is actually an acronym for investigating the structure of paramagnetic aggregates from colloidal emulsions, and the experiment is intended to study the fundamental behavior of magnetic colloidal fluids under the influence of magnetic fields. Colloids are mixtures of one substance microscopically dispersed throughout another substance, and magnetic colloids form rigid lattices that cause the suspension to stiffen when a magnetic field is applied. The study of magnetic colloids on Earth is difficult because in gravity their paramagnetic particles sink while the magnetic field is applied, which affects the formation of the structures they would otherwise create. But observing the structures in microgravity can give us a better understanding of how magnetic surface and repulsion forces interact in magnetically responsive fields, and the lack of gravity on the space station helps scientists do that. Scientists hope that the knowledge they gather from The in-space experiment will be useful for space applications because these fluids are used in electromechanical interfaces and devices in which the fluid is exposed to magnetic fields. Devices such as tunable dampers and brakes, and in the future, possibly robotics, clutches, and a host of other vibration-controlled systems are envisioned. The study also has benefits here on Earth that could improve our ability to design things like bridges and buildings to better withstand earthquake forces. The In-Space 3 experiments have actually been going on since Expedition 27, or the In-Space experiments, including 1 and 2, since Expedition 27 at the space station. And as you can see, they do require some crew involvement, although all of the work is, of course, monitored by scientists here on the ground. All of the work is conducted inside the microgravity science glove box, which is what Karen Nyberg is standing in front of in this video recorded earlier today. A fluid sample in a vial assembly must be uniformly mixed before the test operations. It's one of the activities the crew help with. In all, 36 tests will be performed with 2 or 3 per day. And this is the first day of In-Space 3 activities for the Expedition 36 crew. Once the crew members get it set up, the experiment itself will actually run autonomously with the ground monitoring for about 2 or 3 hours. Then the crew can come and change out the samples and set up another experiment. 3 of these are scheduled to take place over the course of the day, with Nyberg working with all of them. I mentioned before that there is a lot of spacewalk-related work going on board the space station today, but that's also true here on the ground. Astronauts Dan Burbank and Barry Wilmore are spending several hours underwater at the Neutral Buoyancy Laboratory here at the Johnson Space Center today, brushing up on their spacewalking skills. This is a view here of Wilmore working underwater at the Neutral Buoyancy Laboratory. Neutral Buoyancy Laboratory is a 40-foot deep swimming pool that holds 6.2 million gallons of water, and it is 202 by 102 feet and currently holds a mock-up of parts of the International Space Station. Spacewalkers practicing in it, as you see here, are weighted down so that they're neutrally buoyant, hence the name of this facility. That means that they neither float to the top of the pool nor sink to the bottom, and so they're able to float much like they would in space. It's not an exact match for the experience, but it's one of the best ways to practice for a spacewalk here on Earth. Today, Burbank and Wilmore are practicing some generic spacewalk activities that could be required from time to time at the space station. Burbank spent some time up there not too long ago with the Expedition 30 when he was commander. You can see Burbank in this view with on the right-hand side of the screen. Wilmore, meanwhile, is scheduled to make his own trip to the space station before too long as part of the Expedition 41 crew. As you can tell from their space suits, he is actually the lead spacewalker today, and so is wearing a spacesuit that's marked with a solid red stripe. Burbank's spacesuit differentiates between the two of them by being solid white. Although some expeditions to the space station have specific spacewalks scheduled for them, with tasks that the spacewalkers practice extensively before leaving Earth, many crew members don't have a planned spacewalk during their time in space, but that doesn't mean they won't need to perform one.
And go ahead, Karen.
Since they may need to go outside the space station to fix or replace broken equipment at any time, they learn to perform a number of generic spacewalking tasks before they launch the station.
Fold it over lengthwise, like it's called out, and as we're trying to fold it over, the end over, there is some air in there, and it's a little puffy as we fold it. Is that going to be okay, or would you rather we try to redo the seal, cut the seal, and do it a little, just try to get a little more air out?
And give us a second to check.
Flight Engineer Karen Nyberg there reporting down to the Payload Operations Center in Huntsville, Alabama again about the work that she and Parmitano have been doing to get the Missy 8 experiment sealed up and protected for its eventual return to Earth. Again, to keep that experiment, which was retrieved during a spacewalk last month, in the best condition, they want to expose it to as little air as possible, so they're working to get it sealed up in a bag that will keep it safe until it's able to be returned to Earth on SpaceX 5.
Go ahead on 2.
Yeah, we're thinking that it is the best idea to cut this one open because I turned around and saw one of the O2 absorber packs floating, so it must have come out of the bag while we were getting air out. So anyway, we think we probably should cut it open and make sure that this is the one it belongs in, and then try and get more air out.
And Karen, in that case, yeah, we concur with your assessment, and go ahead and try a reseal.
We are currently out of range of video downlink from the International Space Station, so we're going to take advantage of this time to give you a little bit closer look at the crew members who are living aboard the station, Expedition 36 crew. That'll be in the Expedition 36 crew profile that's next on NASA TV, and this is Mission Control Houston.
The members of the International Space Station crew all believe that their 6-month mission is an important part of the work that's needed to help human beings continue to explore well beyond their home planet. Pavel Vinogradov was born in the far eastern Russian town of Magadan and grew up in the even farther eastern town of Anodir, just 500 miles across the Bering Sea from Nome, Alaska.
If you have been to Alaska, then it's pretty much the same. The nature is just fantastic. Of course, the climate is very harsh, 8 months of winter, lots of snow and ice, but I love it. I enjoy it.
After a childhood spent dreaming of becoming a pilot, Vinogradov left Anodir after high school for the Moscow Aviation Institute. He earned a degree in rocket booster design, then taught and did research at the Institute while earning a second degree in computer systems and systems analysis. Vinogradov joined the design bureau of the Rocket Space Corporation Energia in 1983 and worked on the Mir space station, the Buran shuttle, and other Energia vehicles before being selected to Energia's Cosmonaut Corps in 1992. He logged 198 days in space as the board engineer on Mir 24 and made 5 spacewalks to repair Mir after a Progress freighter punched a hole in it in the summer of 1997. He made one more spacewalk in 2006 as commander of the International Space Station's Expedition 13, a 183-day mission that restored the station's crew complement to 3. He believes today's space exploration efforts bear comparison to the sea voyages of the great explorers in the Age of Discovery.
People who were exploring the Earth did not know that they will discover America in 4 months, for example. The risks were great. But I have no doubt that likewise, we, as those explorers, we need to explore space.
Retired Russian Air Force Lieutenant Colonel Alexander Mazurkin is a product of Western Russia. Born in Yurshy-Chi in the Smolensk region and raised a couple of hundred miles away in Oryol. He calls his childhood a typical one and says even as a young boy, he wanted to go places no one had been to before.
I wanted and decided to be a cosmonaut when I was a little boy. When I was a 13 years old guy, I went to the aviation club. There I made parachute jumping. There I was flying on gliders.
Becoming a pilot was next on his list. After school in Oryol, Mazurkin went to the Kasha High Air Force Pilot School in Volgograd, then finished his pilot training at the Armavir Military Aviation Institute in Krasnodar in southern Russia. He spent the next 7 years in the Russian Air Force as a pilot instructor at the Krasnodar Military Aviation Institute, before being selected as a cosmonaut in 2006. Mazurkin shares the philosophical view of the Russian rocket science pioneer Konstantin Tsiolkovsky, who believed that Earth is the cradle of humanity, but that mankind can't stay in the cradle forever.
He was positive that we are going to the space and we will live in in other worlds, in other different places, and the time will come for this. I'm sure. That is why I think we should do this job.
U.S. Navy Commander Chris Cassidy is a native of Salem, Massachusetts, who grew up in York, Maine, on the Atlantic coast. He was aware of the space program as a young boy, but admits he wasn't particularly interested.
I was just like every other boy. I mowed lawns, had a couple odd jobs in restaurants and things in the summertime, but that was all to really pay my gas to drive to the basketball court.
Cassidy left York after high school, first for a year at the Naval Academy Prep School, and then on to Annapolis, where he earned a bachelor's in mathematics. Next stop was San Diego to begin training in special operations as a Navy SEAL. After 4 years stationed in Virginia, he earned a master's in ocean engineering at MIT. And about that time, he became aware of a fellow Navy SEAL who'd had a similar career arc to his, astronaut Bill Shepard.
So one day I actually met him or called him, and he gave me some great information, and I thought, you know what, that sounds really like a really fun job. I think I'd like to do that. So I was probably 26 or 27 when the idea first popped into my head.
Cassidy applied, but didn't get the call from NASA. The next year, just weeks after September 11th, the SEAL platoon he commanded did get the call, and he was deployed to the Afghanistan region before the 1st of October. He returned home to another posting in Virginia, and he was selected for the astronaut program in 2004, just days after coming home from a second deployment to Afghanistan. Cassidy made 3 spacewalks on his first trip to the International Space Station on the 2009 Space Shuttle mission that delivered the components to complete construction of the Kibo Laboratory Complex. He's enthusiastic about his part in laying the groundwork for some future generation of Earthlings to fulfill their destiny to find a new home in space.
But there'll be a time when there'll be people living on other planets. And it's the hard work that we're doing right now, all of us across the globe, that are going to set the stage for that type of environment. Just like Christopher Columbus set sail one day across the ocean. And thanks to those great explorers, we live the life that we do today.
Fyodor Yurchikhin was born and raised in the Black Sea port city of Batumi in Soviet Georgia, growing up in a time and place where all the children wanted to be cosmonauts, where the winners of kids' games were called Gagarins. Yurchikhin wanted to be a part of that life, even if he couldn't be a dashing test pilot.
For what reason I understood maybe in this time, then it's maybe in my health, it's not enough to be a cosmonaut, but what is more important for me, be a pilot or be an engineer in space program. Of course, the space program, it was too important for me.
So after high school, Yurchikhin went to the Moscow Aviation Institute, earned a bachelor's degree in mechanical engineering, specializing in aerospace vehicles, and went straight to work for the Rocket Space Corporation Energia as an engineer. He worked as a flight controller, and when he became lead engineer for the Mir shuttle program, he spent time at NASA's Johnson Space Center supporting that effort. Yurchikhin was selected as an Energia cosmonaut in 1997 and earned a PhD in economics at Moscow Service State University while preparing for his first spaceflight. He was a member of the STS-112 crew that delivered a piece of the station's starboard truss during Expedition 5 in 2002. He returned 5 years later on a Soyuz spacecraft as commander of Expedition 15 and made 3 spacewalks, and followed that with 2 more EVAs as a station flight engineer on Expeditions 24 and 25 in 2010. He believes the station program is paying off in the things we're learning while making the effort, from improving the spacecraft themselves to the tools we develop.
But the first big, exactly great sensor for digital camera, it was factored for this program. And now it's usual for everybody. It's usual for my daughters. It's usual for young boys and girls. I know my profession, it's very important for human. Why I am on this road.
Italian Air Force Major Luca Parmitano is from Sicily, born in Paterno and raised in Catania in the shadow of Mount Etna. Although he was very young when he saw the first space shuttles fly on television, he was captivated by the idea of what those images represented.
So I remember seeing the first astronauts floating around the space shuttle doing their job. And I think that even in a kid, as small as I was, I just thought that must be the greatest job in the world to be able to do those things and call it a living. So since then, I had this dream of becoming an astronaut.
Parmitano won a scholarship to spend a year of high school in Southern California. In that year in America, he not only intensified his desire to be a pilot by living with a host family in which the father was a marine navigator, but he met the girl who years later would become his wife. Back in Italy, Parmitano earned a bachelor's degree in political sciences at the University of Naples and graduated from Italy's Air Force Academy, then completed his basic training at the Euro-NATO Joint Jet Pilot Training Program at Sheppard Air Force Base in Texas. After 6 years with a fighter squadron in Italy, he was sent to France to train as a test pilot and earned a master's in experimental flight test engineering at the Superior Institute of Aeronautics and Space in Toulouse in 2009, the same year he was selected for astronaut training by the European Space Agency. Now he's making his childhood dream a reality and fulfilling a desire to push the boundaries of human knowledge.
That's who we are. That's what makes us humans. That is what makes us different from the rest of the animal kingdom. And if we don't follow our nature of being explorators, of being thinkers, then we are denying a part of ourselves that is incredibly important.
Dr. Karen Nyberg was part of a big family growing up in the tiny town of Vining, Minnesota. And from the time she was a very young girl, she knew she wanted to be an astronaut, although she doesn't know why. She learned some solitary pursuits as a little girl.
I've been sewing. My mom taught me to sew when I was probably 5 or 6 years old. I've been drawing since I was also that age. I would never sit in front of the television just sitting there watching TV. I always had a piece of paper and a pencil and was drawing or doodling or doing something.
But she took advantage of being in a small town to join more school activities than most kids in big city schools join.
I was on the basketball team, the volleyball team, the track team. I took stats for the baseball team. I was in the choir. I was in the band. I was in the drama club. I was able to participate in all of them, learn to be a team member.
She went to the University of North Dakota to study engineering and learned about a program that lets students work at NASA's Johnson Space Center in Houston. Nyberg worked as a co-op in Houston while finishing her bachelor's in mechanical engineering in Grand Forks and while starting her graduate work at the University of Texas at Austin. After she finished a master's and a doctorate in mechanical engineering in Austin, she returned to JSC, working full-time in the Crew and Thermal Systems Division for 2 years before she was picked for the astronaut program in 2000, where she met her future husband, fellow astronaut candidate Doug Hurley. Nyberg was part of the STS-124 space shuttle crew that delivered the Kibo laboratory module and Japanese robotic arm to the International Space Station in 2008, and was the first person to ever operate the shuttle robotic arm, the main station arm, and the Japanese arm. She's confident this mission will appeal to the adventure seeker in today's kids.
I think a lot of it is based just on human nature, that we are all very curious people. Human beings like challenges, and this is an ultimate challenge.
And again was a closer look at the members of the Expedition 36 crew who are currently orbiting about 260 miles above China at the moment. The Pro-K experiment that Luca Parmitano has been taking part in over the course of the week wrapped up for him today with his last urine sample collection, while Karen Nyberg started her second day of the experiment. Pro-K investigates how what astronauts eat can predict and protect against the changes in their bone metabolism while they're in space and once they get back to Earth. NASA studies on the effect of space flight on bones in several different experiments, but this is actually the first experiment that looks at whether diet can be used as a countermeasure. The experiment's proposal is that a decrease in the animal protein to potassium ratio in an astronaut's diet will lead to less loss of bone mineral. And during their stay at the station, the crew members who are participating in this experiment go through 5 dietary intake sessions, 5 blood collections, and 5 24-hour urine collections. During the intake sessions, the crew members would eat either a high or low ratio of animal protein to potassium for 5 days straight, while taking urine samples each morning when they wake up. On the 4th and 5th day, they take additional urine samples throughout the day, and then on the 5th and final day, they take blood samples. The samples are returned to Earth for study, and in all 16 crew members are to participate in the study, which started back during Expedition 21. If this works, it would be a very countermeasure for astronauts because it doesn't require any extra effort for the crew, just an adjustment in their diet. Again, Parmitano wrapped up his last day of special diet yesterday, but had one more urine collection to perform today, while Nyberg is on her second day of special diet and also is performing a urine sample collection as well. And those 2 crew members are also still participating in the reaction self-test experiment today. They performed their first test of the day as soon as they woke up and plan to do another one before they go to sleep for the night. The full name of that experiment is Reaction Self-Test Psychometer Vigilance Self-Test on the International Space Station. It involves a 5-minute activity that allows the crew members on the station to monitor the daily effects of fatigue on their performance, helping them to identify when their performance is degraded by fatigue-related conditions that can occur as a result of living in space. That includes things like problems sleeping, shifts in sleep schedules, and spacewalks, as well as other disruptions in their schedule, such as extended activity periods, such as they have had this week with the arrival of Progress 52 last week on Saturday. To test how this affects their fatigue and their activity levels, the crew members perform 5-minute tests before and during as well as after their missions. And those tests involve the presentation of a series of randomly timed visual stimuli displayed on a laptop. The crew responds when they see them by pressing buttons on the keyboard, and the reaction times are recorded. The test will hopefully help crew members objectively identify when their performance capability is degraded due to fatigue, which is a high priority for NASA's behavioral health and performance research. In addition, the 5-minute test is derived from an original 10-minute psychometer vigilance test, which could also be used to measure lapses of attention, wake state, instability, impulsivity induced by fatigue, and other performance-degrading factors here on the Earth.
On Spaceground 2.
Go ahead on 2, Karen.
We were able to open up and get most of the air out, or a lot better job of the Ormate, but unfortunately there were 5 O2 absorbers in there, which means the one we found must have escaped from the PEC bag. So the question is, do you want us to let it go with 4 absorber packs, or do you want us to cut open the seal and do it all over?
Karen, we are good with 4. And a little bit of puffiness on that air is also okay.
Okay, I think everything's good to go then. We'll finish up the packing and the bubble wrap and stuff, and then we'll be done.
All right, fantastic. Thank you.
Nyberg there reporting to the Payload Operations Center in Huntsville that it sounds like she and Parmitano have gotten a good seal on the Missy 8 experiment, which they've been wrapping up for eventual return to Earth. We're now coming up on the end of today's Space Station Live for the week.
Munich Station Luca on 2, go ahead.
Hi Luca, this is Lionel. We would like to have your permission to come on board for the ESA crew conference coming up.
Julio, you're welcome on board anytime.
Jay, thank you very much.
Live view here of Parmitano and Nyberg working inside the Kibo laboratory. As I was saying, we're now coming to the end of today's Space Station Live for the week. Coming up next on NASA TV, you'll get a look at some of the other activities going on at NASA centers around the country in the NASA TV video file. That begins at 11 a.m. Central, top of the hour. And then afterwards, you can stay tuned at 11:40 a.m. for a chance to hear Nyberg and Chris Cassidy talking with reporters from the Minnesota Public Radio Station and the U.S. Navy's Emerging Media Division. That again is coming up at 11:40 a.m. Central Time. Then another reminder that we'll be back at 2 p.m. Central tomorrow for coverage of the HTV launch from the Tanegashima Space Center in Japan. That launch will take place at 2:48 p.m. Central Time, and again, we'll start coverage of it at 2 p.m. Then on Monday, you'll want to tune in a bit early at 7:30 a.m. Central Time. Luca Parmitano will be talking with Italian media for about 20 minutes. Then we'll be back at our regular 10 a.m. Central Time for Space Station Live next week. So, lots coming up here next on NASA TV, and this is Mission Control Houston.